Hi, I'm Matilda.
And I'm Atta.
Today, we are looking at the most common mistake in algebra.
Easy. X times something is 6. So x is 6, or the bracket is 6.
Wait, this logic only works if the right side is 0.
It's called the zero product property. It only works for 0.
So we have to expand and move everything to one side first?
Exactly, then make it equal to 0.
Now we factor two numbers that multiply to -6 and add to -5.
That gives us two correct solutions, 6 and -1.
See? -1 works perfectly, but our forbidden move gave us 11, which fails.
Never set factors to anything but 0. It's a trap.
Okay, we need two numbers that multiply to -5 and add to 3.
If we try -1 and 5, the sum is 4. That's not right.
What about 1 and -5? Sum is -4. Still no. Matilda, none of these work.
Don't worry, Atta. Some quadratics just don't have nice integer factors. For these stubborn equations, we use the quadratic formula. Let's derive it. We start with the general form, ax squared plus bx plus c equals 0. Finally, isolate x. This is the quadratic formula, our master key.
Okay, let's solve x squared plus 3x minus 5 equals 0.
Step 1. Identify the coefficients. A is 1, B is 3, and C is -5.
Plug them in. -b becomes -3, and we square b inside.
Careful with the signs. -4 times -5 becomes +20.
So we're left with x equals -3 plus or minus the root of 29, all over 2.
Can you simplify the square root of 29?
Nope. 29 is prime. It's not a pretty number.
It's an exact value. In math, exact is better than pretty. Final challenge. Same problem, two methods. Efficiency is key. Ready? Go. I need factors of -12 that add to -4.
Substitution. Square the -4. Careful.
Done. 6 and -2. I'm going for coffee.
Wait, 16 plus 48 is 64, and the square root of 64 is 8.
Got it. 6 and -2. Same answer.
Exactly. The formula is a sledgehammer. It works on everything, but it's overkill for nice problems. Check for factors first. If it looks impossible, then bring out the formula. Subscribe to Matilda Academy and master the art of choosing the right tool.